Let's start by pointing out that the period of a tangent is going to be pi. That means if our period is pi, that we're going to get in important points or important values. So it's going to be our period divided by 4. So every pi over 4, we're going to get an important point. So these blue tick marks that I marked are the distance between pi over 4. So from the origin to this point is pi over 4. From this pi over 4 to my black tick mark is another pi over 4. So all of these tick marks between the black and the blue are separated by a pi over 4 distance. Okay. Something else that we have to understand is that there's an actual pattern to tangents, and that is going to be this that I just wrote down a couple seconds ago. So if your A, basically if you have an A value here is greater than 0, your actual tangent pattern is going to be asymptote, middle point, low point, middle point, high point, asymptote. If your A value is less than 0, this one's greater than 0, less than 0, you're going to have asymptote, high, middle, low, asymptote. But to make it easier for you guys to figure out how to graph the tangent functions, we're kind of going to start like we did for sine and cosine. We're going to start at the origin for our parent function. So that means that we are going to start at our middle point, high and asymptote. So the other asymptotes will be on the left side of our origin point. So we're going to have starts at the middle. So our parent function starts literally at the origin. Then you're going to have a high point at the 1 pi over 4 because we're getting our important points. And then we're going to have an asymptote. So that means for this function, we're going to have just the right side of that curve. And then we're going to start the whole pattern again, this whole pattern to the right side. So we're going to have our low point, our middle point, our high point, which is here, and then we're going to have an asymptote. And we just draw our sine curve. So hopefully I could draw a better sine curve than that. That's not the best, but there it is. And we keep doing the same thing. We have our low point, our middle, our high point, and then we have our asymptote, and we draw our cosine curve. Okay, to me, it kind of bugs me that I only have that red piece on the right side, and I kind of want to extend it to the left. So I know I had a high point and middle, so that means this should have been a low point and this should have been an asymptote. So I could finish my curve right there. And I could keep doing the same thing. I have a high, a middle, a low, an asymptote. A high, a middle, a low. It depends also what way you start your pattern. So again, if you do your pattern from the left to right, then it's going to be an asymptote, a low point, a middle point, a high point, asymptote. Again, a low point, a middle point, a high point, asymptote. Just so you understand, this right here, this piece with this asymptote and this piece is one period length. And that's where you complete one cycle. Because the length should be up to here. So one period is pi. So that's the length. So you could say that the period, if you're going from the parent function, it starts from here and it's completed there. It's one length of period. Together, these two graphs make one cycle, but technically one cycle, basically remember the shape is a cycle, is one whole curve. From here to here, that is one period length of pi, and it's completed one cycle. You could also say one period is from this point right here, with this middle point, high point, asymptote, then your low point and middle point, that completes also one cycle of a length of a period of pi. Just like our other functions, we notice that there are still important values. However, they occur every pi over 4 in this case for their parent function, like we stated earlier on the top. And you can still find important values by dividing the period by 4. That has not changed. That's still the same. The rest of the stuff you could actually just kind of figure out. And again, a sinusoidal means a wave function like sine and cosine, something that goes like this. Again, cosecant and secant are not sinusoidal, and also tangent and cotangent are not sinusoidal. Anything that's sinusoidal, which is like a wave function, would be sine or cosine. Okay, so let's start by answering the bottom part of our chart. We already know that tangents and cotangents and secants and cosecants, they technically do not have an amplitude because they're not sinusoidal, which means they don't have a wave function, so they don't have a distance between the midline and your max and min numbers. So if we look at the function that we currently have, you could also notice that we don't have no phase shift, so that's none. Our important values, if we remember again, we have to figure out what our period is. So let's do our period first. So we know that our period for a tangent function is pi over our b, and we know that b in this case, if we notice right here, that's our frequency, is going to be 2. So we're going to have pi divided by 2 is going to be our period. We're going to complete one period or one cycle of the tangent function in that length. To find our important points, we're going to have that pi over 2 divided by 4, which means you're going to have pi over 2 times a fourth, which means we're going to get an important point every pi over 8. We're going to get an important point. There is no vertical shift, so there's none. And it is reflected because we have a negative right there, so it will be reflected. So this one's not gonna start since our a is less than 0 because it's a negative. Our function will decrease. So basically, we're gonna have it start at asymptote, high, middle, low, asymptote. That would be the pattern for the rest of it. But that means when you're first starting your parent function, you go middle, low, and asymptote. Okay, because remember, we want our graph to start at the origin for our parent function since there was no shift. So let's label our graph. So give me a second. Okay, so I labeled my graph. I know that this one, because it was reflected, it's going to still start the middle, but instead of going high, I'm going to go low. And each one is separated by a eighth. So now we have something that looks like this. And then we have high, middle, low, asymptote. And then again, we have high, middle, low, asymptote. And if we continue our function, this would be our high, our asymptote. And then we would have again low, middle, high, asymptote, low, middle, high, asymptote. And I'm just finishing the graph, completing the whole graph from left to right, and using that pattern that I accomplished on the right side. So this would be our function y equals negative tangent of 2 theta. Just to point out, we have that this piece right here, this asymptote, and this piece, now right there, that is a period pi over 2 that completes one cycle.